Hello, everyone. Thank you for joining. My name is Kirill Tropin. I'm product manager in Google Cloud Storage.
And my name's Chris Talbot. I'm Kirill's counterpart in the product marketing organization.
Today, we'll be talking about picking the right storage class. And before we begin, I want to give you a quick overview of this presentation. So we'll be talking primarily about object storage. We'll not be talking about different databases. And we'll start at high level and go lower and lower into details of how to optimize performance of your storage and choosing the right storage class for your needs. To start, I want to show you how storage is used across different industries and different verticals. And we can go into all the details about each and every vertical, but the reality is storage is used across the board for every single vertical. And if you're not using storage, probably you should look into how you can start leveraging the data, leveraging that storage, because getting insights out of your storage can really transform your business. You can open a new market, new opportunity, or help optimize your cost, or ship new products for your customers and your consumers. And to get into a couple examples here, so storage is used, for instance, for multimedia to store all the content, serving that content to end users, storing different transcodes of that content. For retail, you'll be looking at different ways to analyze logs, what your customers are buying, creating different insights and helping sell you more. Then looking at healthcare, for instance, there's lots of data with genomics. Genomes are very large, and you'll be storing that huge amounts of data and in Google Cloud Storage. I want to tell you a little bit about journeys that we see from our customers. And there are three typical steps that we see from our customers, how they transition to cloud. So first step is called hybrid infrastructure. So that's when your control is still on-prem and you're just getting started with cloud. Typically what we see is different bursting scenarios. You're just bursting your compute into the cloud, or you're archiving data to the cloud. You're just getting started. And what we see with cloud storage in those cases, typically it's different archival, different backup scenarios, and customers will be leveraging our core compute, core storage, and networking infrastructure. And going a level deeper, next stage in the cloud journey is typically lift and shift. You're just lifting your workloads, moving them to the cloud without really changing them much. And some typical examples is moving your databases like SQL databases, moving your Hadoop, and then you'll end up leveraging some of our existing products like Google Cloud Storage for storing that Hadoop data or storing different static content. And you'll be relying on Google Cloud Platform for your scalability and scaling to much bigger capacity and making it much easier for your workloads. And then last stage is running cloud native. That's when you build your apps, build your workloads directly in the cloud. And typically what we see there is people will be leveraging our BigQuery, our machine learning, our Spanner, App Engine, and of course leveraging cloud storage for storing and serving and analyzing the rich content. Let's talk a little bit about evolution of storage. So we did not arrive in object storage out of the blue. So it all started with directly attached storage. And directly attached storage is our typical laptops and desktops. That's where you have storage right next to your compute, right next to your cores. And everything was fine. It was growing fine. People were running applications on a single box. But then people realized that it's not efficient. You cannot optimize storage and compute at the same time and fully utilize your CPUs and fully utilize your storage. So over time, people realized that we should separate storage from compute. And that allows you to optimize storage separately from your compute and run at full utilization, both of those. And that's where SAN came from. And with SAN, people had to manage different volumes. This is volume for this workload, that volume for that workload. And they got tired, and they figured out they can move to level higher and move to network-attached storage, where they operate on files instead of on volumes. And then over time, amount of data just kept on growing. Now we have huge amounts of data, and industries realized that they can no longer rely on file API for scalability, so they shifted to very simple object storage API that allows you to scale to huge amounts of data, petabytes, even exabytes, and trillions of objects in the cloud. And so today's presentation will be focused on Google Cloud Storage. That's our object storage in the cloud. And to introduce, Google Cloud Storage is highly available, durable, simple, and secure object storage in Google Cloud Platform. We call it GCS for short. And we see a lot of success across different use cases with GCS and Google Cloud Platform. GCS is built on the same infrastructure as other internal services at Google, and we actually have quite a few internal customers at Google using underlying infrastructure for object storage and serving, and I'm sure you're using lots of external Google services that depend on that exact infrastructure. I can summarize use cases with GCS in like three large categories. The first category is content storage and delivery. We see a lot of demand there. So that's video serving, image storage, image serving, music serving, and Some customers that you've heard about is probably Vimeo for serving videos, Spotify for serving music, and lots of other customers that store and serve content out of DCS. And then moving to second category, that's typically big data analytics and general compute. If you have a lot of data, petabytes, hundreds of petabytes, exabytes, you got to store that huge amount of data. And for general compute and general big data analytics use cases, you'll probably end up storing that data in DCS. And some examples from different verticals that we see is healthcare, with different genomics analytics, manufacturing, financial data analytics, e-commerce, et cetera, et cetera. And last but not least is backup and archival use cases. And I'm showing quite a few of our partners here, and we have a long list of partners that can help you move to the cloud and back up or archive your data to the cloud. So with DCS, with Google Cloud Storage, we have 4 use cases that target different needs of your workloads and different needs of different verticals. So I'll start left to right. So left is our multi-regional storage. That's geo-redundant storage. It's optimized for business continuity because it's geo-redundant out of the box. And it's also great for content serving and delivery because data is distributed in our network, and it's the highest level of availability across all of the storage classes. So typical use cases, it's serving videos, serving images, and different websites and different documents as well. Then second storage class, it's regional. Again, it's optimized for hot storage, hot data, but it's limited to a single region. And what that allows you to do is to have your compute and storage in one single region. That way you have lowest latency and highest throughput between your compute and your storage. And so that's typically where you see examples of video transcoding, different genomics, and different general compute and data analytics. If you're running Hadoop workload, you'll be using regional storage along with your DCE cluster. And then going to the right, we have colder storage. So nearline is our storage for infrequently accessed data. Rule of thumb which we typically give is if your data is accessed less than once a month on average, or you read 100% of your data per month or less, then nearline will be the cheapest storage class for you. And moving to even colder tier, that's cold line. With cold line, it's still online storage, but with cold line, if your data accessed less than once a year on average, that becomes your cheapest storage class. And typical use cases that we see from customers, they start with their content in multi-regional or regional storage. That content is very actively used. After a couple of months, people realize that that content is no longer that frequently used, and they typically tear it down to nearline. So like think of your document, you create a document, you'll be sharing it with your colleagues, and after a couple of months, the document won't be that frequently accessed, so it's natural to tear it down to nearline, and then after a year, probably no one will ever look at the document again, so you can tear down all the way to cold line. But before you take all advantage or full advantage of these storage classes, you need to get your data in to GCS.
Yeah, and we sort of skipped ahead. So, one of the things that we talk about here at Google are some of the challenges associated with how do you get your data to the cloud. And try as we might, we can't move stuff faster than the speed of light. So depending on the kind of data that you have, the amount of data that you have for a particular workload, and then whatever your network situation may be, you're facing a wide gamut of ranges when it comes to the amount of time that it'll take to move that data to the cloud. In addition to those sort of challenges that come from the infrastructure side and what your situation may be, you also have particular needs for your role. So generally when we talk to customers, we kind of see folks falling into 3 buckets, right? So IT infrastructure folks, analysts and marketers, and then application developers. So the IT infrastructure folks, when we talk to them, they typically have a need to move their data from either a current on-premises data center or from one cloud to another. And what ends up being the characteristics of their data is that it's large amounts of data, so typically multiple petabytes, and they need to bulk upload that data to the cloud without affecting their current network situation and their current operations. Now, analysts and marketers, they're dealing with data that's streaming. They want real-time insights into that data. They want to learn about their customers as quickly as possible by getting data about their customers into analytics tools. So typically, they're streaming data, and they need to automate data transfers from particular applications into analytics tools in the cloud. And then finally, developers, they need to build applications. So they want to transfer their data essentially with a natural fit into their development workflow. So they want to use the network to transfer their data into the cloud. So whatever your situation may be, whether you're on the IT infrastructure side, or you're an analyst and marketer, or you're a developer, we've got options at Google for moving that data into the cloud. So if you have on-premises data and a really good network, you can use our GSUtil, our command line interface, to move your data using the network. If you are in another cloud storage provider, for example, Amazon S3, you could use a cloud storage transfer service to move your data from one cloud to another. And if you're on-premises data and maybe you have a bad network situation or you have tons of data that you need to move, we have offline option called Transfer Appliance, and I'll talk a little bit more about that in a second. And then finally, for those analysts and marketers out there who are using a lot of our other tools, we have a transfer service that can get your marketing data directly into BigQuery, which is our data warehousing solution, and get you analyzing that data as quickly as possible. Now, across all of these sort of buckets of areas of transfer services, we also have partners out there that can help you move your data faster. Now, I mentioned something called Transfer Appliance, and I wanted to highlight this one particular solution because it's a relatively recent solution that Google has released. And this is our rackable high-capacity storage server for moving data without using the network. So something that's really interesting about this solution is we designed it in particular for data centers. So you can order this appliance from Google, we ship it to you, you stick it in your data center, you rack it, it lives there for a while you upload your data, and then you ship it right back to us and your data is available for all those great services that Krill mentioned in GCS.
All right, so let's go one storage class at a time and deep dive and talk about different use cases and how to optimize your storage needs with those storage classes. I'll start with multi-regional storage. Multi-regional storage is best for content serving and delivery. So our multi-regional storage is geo-redundant out of the box. We have simple pricing and simple API to achieve the geo-redundancy, and it's really simple for business continuity. It provides highest level of availability. It optimally routes data within Google Network. Currently, it's available in 3 multi-regional locations. It's US, Europe, or Asia. So for instance, if you select US, we'll automatically handle storing data and routing within our network within US. If you select Europe, the same story applies. We'll automatically store data in a geo-redundant way within Europe and make sure that we have at least 2 replicas and you have highest level of availability for the data. And common use cases for the storage class, as I said before, is streaming videos, streaming music, or just having a great level of business continuity because we take care of all failovers. You don't need to worry about manually failover from primary to secondary. We take care of all of that. And to show how really simple it is, I want to show you a couple APIs. So first one is creating a bucket. So that's GSUtil make bucket, multi-regional location in US, and then name of my bucket. And that's it. As you see, there is no primary, there is no secondary region. I'm just specifying that store my data in US, and then we take care of all the replication on Google side. And then similarly, retrieving the data with GET, standard HTTP GET, this is my bucket name, Kirill USMR, standard domain name from DCS, and then name of my object, which is image.jpg. And again, there is no primary, there is no secondary location. What's cool about it, if something happens to one of our regions, we'll automatically fail over and route your request to secondary location or tertiary location, wherever we have your data. And that means no downtime in case of regional failure on your side, because you don't need to manually switch from primary to secondary or worry about implementing that code for switching from primary to secondary. In a similar way, the storage class is optimized for end-user latency. So we'll be serving data from the closest available region or closest available location from where the request came from. We'll also cache data in the regions that are nearest to those end users that are accessing that data. And if you mark your data as public, that means it's like cacheable and like far edges of our network. We'll cache it in more than 100 points of presence from where the data was accessed from. And to talk a little bit more about that caching, there is quite a few things that are embedded with this multi-regional storage and DCS in general. So I want to spend a minute and explain how does this multi-regional storage compares to standard solutions in the market. So typically what you see from other cloud providers or standard applications, how you store your data, your consumers would go directly over public internet or over different providers to location or that region where the data is stored. For instance, in this picture, consumers from a laptop is going directly to region B. With DCS, our approach is very different. So you'll hit the closest point of presence on Google Network, and Google Network is huge. Like Google works really well, and we leverage the same network with the DCS. And so you'll hit the closest point of presence. If your objects are marked as public, we'll check in the cache, do we have this data in the cache? And then we'll serve it directly out of the cache without going all the way to storage level. And if we don't have the data in the cache, we'll figure out which region is closest to this location. It's region A or region B, and we'll serve data directly out of that region whichever one is closest. And that really helps optimize end-user latency. And some of our customers, for highly cacheable data, they get insane performance. They get like millisecond level performance for serving data out of those POPs. In terms of pricing, as I said before, pricing is very simple. We charge a simple 2.6 cents per gigabyte month in this multi-regional location, and that's per logical data. We don't charge you for primary replica or secondary replica. We don't charge you for replication of data between those two regions. Everything is included in terms of storage in this price. And so it's geo-redundant. We take care of this replication. For reads and writes, we have industry standard price for how much we charge, and it's really like super low, 0.4 cents per 10,000 operations for reads, and 0.5 for 1,000 operations for writes. We provide highest level of availability. That's 3.5 nines availability SLA for this product, and it operates at even higher. It's designed for even higher availability than these 3.5 nines. And again, industry standard 11 nines for annual durability, and we have the same 11 nines across all of our products for durability. Before we deep dive into how to optimize your performance with different storage classes, I want to show you how we lay out data in simple terms, and that really will help you intuition for how to use the storage classes in which situations. So starting with multi-regional, very simplistic view, it's two replicas, and we have these two replicas in two different regions. So as you see in this chart, you may not have all of your data in each particular region. So you will not have all of your data in region A, region B, or region C, but for each object, we'll have two replicas that are geo-redundant, and we do the geo-redundant, that replication in a synchronous way. And so, for instance, if you're serving this content, there is no guarantee that all of it will be in each particular region, but we'll have two replicas of that content. Then going to regional storage, situation with regional is different. So for instance, if you selected region B for your regional storage, all of your data will be in that region B. It will be redundant across availability zones within region B, and all of it will be within that single region. So that means if you select your compute cluster in that same region, you'll have highest level of performance between your storage and compute because all of your data is in that region. You don't need to go across regions on our network. And then with nearline and cold line, if you select multi-regional location for nearline and cold line, those two storage classes are not geo-redundant, which is different from our multi-regional storage class. But with nearline and cold line, it will be stored in one of the regions that are part of that multi-region. With nearline and cold line, you also have an option to select the regional location. You can say, store all my data in region B, and in that case, it will behave very similarly to regional storage class, where all of the data is in one region. Let's talk a little bit about those best practices. So as you might understand, you want to take full advantage of our network. And when you think about our network, you don't want to proxy everything through a single location. You want your end consumers directly accessing GCS, and that will allow you to scale to TBPS, 1 terabit per second speeds, because you'll be taking full advantage of Google Network instead of trying to go through a single endpoint or single POP. And that's really the way for our customers to scale to huge, huge volumes of traffic. Then a similar way, if you have lots of requests coming to those objects, please parallelize them, because that will also allow you to take full advantage of our network with having lots of parallel requests coming at the same time. And then favor larger requests, because larger objects will move faster on our amazing network, and parallelize small operations. Just keep parallelizing everything. Don't have those sequential operations. Like, it doesn't make sense to have millions sequential operations. If you can parallelize them, all of them will complete faster if they're going in parallel. And some rules of thumb. For a single stream for write, we have roughly half a Gbps. For a single stream of read, we have roughly 1 Gbps. And if you parallelize, it scales almost linearly with having multiple streams accessing GCS in parallel.
Yeah, so multi-regional storage, it's the storage class that a lot of our customers use for serving their content to users throughout the globe. So we've been talking a lot, and we've been talking very fast, and we want to switch it up a little bit and show everyone a demo, a very simple demo of the few steps that it takes to upload your content into GCS. And then we're going to show one of the unique differentiators, the built-in edge cache that Kirill mentioned. And we're also going to switch up roles. So we've had the product guy pitching the whole time. And we're going to have the marketer actually demo the product. So I'm going to switch over to the console. And once I get there, I'm going to reconnect because we've been, as I said, talking for a little while. So for those of you who are unfamiliar, what you're looking at is the Google Cloud Platform console. This is how all of our users and customers they interact with all of the services that Google Cloud provides. So you can see all of these services over here on the left-hand navigation. We're going to store some stuff, so I need to use some storage, very obviously. So I'm going to go into the storage browser, And for the purposes of this demo, we're just going to create a bucket, and we're going to upload an image. So as Kirill mentioned, the way that object storage works is you organize your data into these buckets into which you put your data. So I'm going to create a new bucket here, and I'm just going to name it, let's name it the Cloud OnAir Demo Bucket. We'll select multi-regional, so we were just talking about multi-regional. And we'll have that data live in the US, and we'll create that bucket. So now I have my bucket, and I need to find some data to put into it. So I'm going to upload some files. And I have a list of various images that I've used for demos.
I hope they're good.
You saw our Lego chicken, so why not use the image from the slide? And we will upload this Lego chicken. And there you go. Here is our Lego chicken image in our multi-regional US bucket. It's as simple as that, right? A few steps to get your data into GCS. And once your data is there, you can serve it to content, or you can serve it to users throughout the globe, or expose it to any other services that are available from Google Cloud Platform. Now, I mentioned I wanted to show one of the unique differentiators that comes from GCS and that global built-in edge caching that we do. So it's really hard for me to simulate a user at this point in time requesting data from like London, for instance, from here. So what I could do is I could show you us requesting data from a bucket that's perhaps a multi-regional bucket in the EU. So I'll go back to my storage browser. And you can see I have various buckets in various locations throughout the globe. I will go to this Chris's EU bucket. In it, I have our Lego chicken image. And I'm going to run a simple script. And essentially what I'm going to ask it is to tell me how long it takes to request this image from that bucket in the EU. So let's run this. And you can see down here this 799 milliseconds, so which is pretty good, right? It's going a long way to request this information.
From the other side of the planet.
From the other side of the planet, yes. But we can do better, right? So I mentioned, unique to Google, we have that global built-in edge cache. So I need to enable that edge caching. So I'm going to share this Lego chicken image publicly. I'm just going to make sure that the cache control is cleared out here. And now that I've done that, I've essentially enabled that edge caching. And we're going to run our script again, getting a little bit better, 526 milliseconds. And there you go, down to 31 milliseconds. So a massive, massive difference in how fast a user would be able to get that content, because Google is essentially trying to push it as close as possible to me requesting that information from the EU. So for you as customers of GCS, whether you're in Tokyo or you have users in Tokyo or London or Mumbai, we're basically going to try to give those users requesting your content the best experience possible for content serving.
Yeah, that's phenomenal. And it was 1 megabyte object or something like that.
Yeah, it was a pretty big object.
Yeah.
The Lego chicken was a large image. Yes.
Large chicken. All right, so let's switch back to our storage classes, and we'll talk about regional storage class now. So regional storage is the storage that's best for data analytics, and it's really best for data analytics because you can select a region where to store your data, and you can run your compute and run different cloud platform tools within the same region. It's redundant within the region. It's redundant across multiple availability zones to achieve that high level of availability. And it's integrated with all the standard Google Cloud Platform tools or products like Dataflow, ML, BigQuery, Cloud Genomics, and obviously Compute Engine. But this is really the storage class to use with all those tools. It's ideal for running general compute within a single region, different data analytics use cases with Hadoop, with Cloud Dataprog, Dataflow, also for serving that content within one constrained geographic location. And you can also use the storage class for region shielding with content delivery networks if you want to have predictability on latency, where your data is stored and where you're exiting our network with CDN shielding, for instance. Let me show you an example of using the storage class with Hadoop. So we talked about that lift and shift use case for our customers on their journey to cloud. And for customers that already have Hadoop clusters on-prem and they want to lift and shift them to the cloud and run that workload in the cloud, we have a perfect product for that. It's called Cloud Dataprog. It's essentially managed Spark and Hadoop service on cloud storage. And what's cool about that product is that it has Cloud Storage Connector, and that connector is HCFS compliant. So that means to migrate your storage to GCS with Hadoop, all you need to do is just change your pointer to where your data is stored. Instead of having HDFS pointer, you're just having GS pointer, and that's it. You don't need to do any other changes with the storage. You just change where your data is stored, essentially upload it to DCS, change from HDFS to GS, and you're done. Like, everything else will keep on working. And what's great about using Google Cloud Storage versus using Hadoop on-prem is that you can shut down your cluster, and your data will still be there in DCS. You can spin up another cluster and access the data, so the data is accessible when your cluster is turned down. And that allows you to save a lot of money on that compute capacity. You can scale down, scale up your compute cluster independently from storage. And you can learn more about Dataproc and that cloud storage connector on cloudgoogle.com/dataproc. In terms of pricing structure is very similar to multi-regional. Again, it's simple. In case of regional, it's 2 cents per gigabyte month versus 2.6 cents per gigabyte month. And pricing is slightly different around the world, but this is our typical price in US, Europe, and major locations in Asia. Read operations, write operations are the same as with multi-regional storage. Our availability SLAs is 3 nines, and this product is designed to run at even higher availability. Again, all the standard stuff, the same durability, the same instant access, the same API. So as you saw, it was very simple to create multi-regional bucket. API is exactly the same for regional storage. You specify that it's regional storage and not multi-regional. In terms of best practices for using regional and optimizing that performance, when you're running those analytics workloads, when you're accessing storage from compute engine, you should be co-locating your data and compute. You should be really selecting the same region for storing your data and where you run your compute jobs, because it decreases your latency. Make sure you have the highest throughput. It also optimizes your predictability, because you have predictable tail latency since your data is co-located with your compute. And all the standard stuff parallelize your operations, because you can still take full advantage of the network within a single region. Let's talk about cool data. So for cool data, we have 2 storage classes. That's nearline and coldline. I'll start with nearline. So nearline is our storage class that's best for infrequently accessed data. It has the same online latency, the same API as other storage classes. Common use cases is serving long-tail content. So remember, I said it has online latency. So you can still use the storage class for serving your content. But if it's that content not that actively used, just put it in nearline and serve it directly out of nearline. In terms of storage price, we charge significantly less. We charge only 1 cent per gigabyte month, but we charge 1 cent per gigabyte read. And those 2 numbers work out to that rule of thumb that if your data is accessed less than once a month on average, nearline is really the cheapest storage class for you. Couple other differences versus nearline and regional. So minimal storage duration in nearline is 30 days. We did not have that concept for our hot storage class. With nearline, we have it simply because we charge so little for that storage. And this storage class is designed for longer-lived content versus regional, where you can have temporary stored data. And then slightly lower availability SLA. Again, we optimize this product for that lower price, and infrequent access. So our availability SLA is 2 nines, but it's designed to run at 3 nines of availability. And then moving to coldline. So coldline, you'll see, is very, very similar to nearline. So with coldline, we still have online latency. You can still actually use the storage class for serving your content. It's the same API, the same consistent API as any other storage class.
1 second, though. So it's archive storage that has millisecond latency?
Yeah, it's archive storage with online latency. As I say, it's archive storage that you can actually use. Because you can archive data, and whenever you need it, you can still access it, use it anytime you need. You don't need to wait for that retrieval from tape or any other semi-offline or offline storage that you're using. And we have some customers that actually use coldline for serving content. Customers that have just huge amount of content and that really long-tail content, they put some parts of the content in coldline, and they still serve it out just because it's not accessed frequently. And in terms of pricing, it's lower than nearline for storage. It's 0.7 cents per gigabyte month, and we charge more for data access. And those 2 numbers work out to the rule of thumb. That's if your data access less than once a year on average, then coldline is the cheapest storage class. Just to show you how consistent that API and that performance is. So with API, it will look exactly the same how I was showing with multi-regional storage. So my bucket is called coldline. I've claimed that name for my storage class. Again, same domain name and image.jpg and the standard get and put interface for getting the data in and out. For performance, I'm showing gsutil perfdiag. So it's similar to the tool that Chris was showing, but with perfdiag as our perf diagnostic as part of gsutil, which is our storage utility. And here I was downloading 1 megabyte objects out of cold line. I was not as far as London versus US in that example. But at that case, when I was testing it, I was in London and data was in Belgium. So there was a little bit of extra hop there. And you can see in this example, its consistent performance is between 147 milliseconds up to 200 milliseconds for loading that 1 megabyte object out of cold line. That's crazy. That's our archive storage.
So if we had wanted to, I could have served that Lego chicken image out of cold line. You know, if someone was requesting that image, for instance, and it would have given them the same experience had we had it in
That's right.
Another storage class.
That's right. It's still online storage. Still relies on the same Google network, so it would be just as fast. Let's talk about using storage classes together. I want to remind you, again, all of the storage classes that we have, because we have quite a few of them, 4. And so multi-regional is our storage for content serving and delivery. It's geo-redundant. It's available in 3 multi-regional locations worldwide, US, EU, and Asia. And we charge 2.6 cents per gigabyte month. Simple price per logical gigabyte month that you're storing. Then going to the right, we have regional, which is storage optimized for access within a single region. We charge 2 cents per gigabyte month of storage, so it's slightly cheaper. And then nearline and cold line is infrequently accessed storage and cold storage. And that's for those storage classes, we charge much less for storage, but we charge more for access. And typical rule of thumb that for nearline, it's data access that accessed once a month or less, and cold line access once a year or less. And what's cool about all these storage classes is that they have the same API. And having that API allowed us to have object-level storage class and data lifecycle across all of those storage classes. And you can really transition between storage classes very smoothly. And without changing URL, without changing your API, how you interact with your data, you can simply change the storage class, and all of your tools will keep working. So to simplify that lifecycle for you, we created data lifecycle across storage classes. That's a feature that we launched about a year ago. And we allow you to automatically set policies and transition data from hot storage to cold storage based on the age of the data. So a typical example that we see is for documents, as I was telling earlier. Within the first 30 days, that document is accessed very frequently, people interacting, editing the document, and so you will probably be storing it in multi-regional storage class. After 30 days, you can set a policy to move it down or tier it down to nearline, and then after another 90 days or 180 days, you can say tier down to cold line. And GCS will take care of that tiering down, and you don't need to change anything. Your API is the same, your bucket name is the same, your object name is the same. All of your code will keep on working, even if the document ends up in our coldest tier. All the stuff will keep on working with the same API. All right, so some closing notes before we switch to Q&A. So I want to remind you, we have 4 storage classes. They're tuned for different use cases for object storage. We have the same API, the same online latency across all of them. And that really simplifies your management of your data and how you access that data. All of these storage classes rely on Google Network and our peering. We have open peering policy with Google Cloud Platform. We have lifecycle across all of the storage classes. You can learn more about us if you just Google Cloud Storage, or just go to cloudgoogle.com/storage. We have free tier and free trial with GCS, so please go ahead and try it out, upload your Lego chickens, and see how fast they are. Yeah, that's all I had. So we're going to take a minute break, and then we'll switch to Q&A, and we'll be back.
Yeah, thank you so much.
Thank you. All right, thank you for listening to us. So we have quite a few questions coming online, and so we'll try to answer as many of them as we can. So we'll start with the first one. When will GCS be available in my country? And so what's interesting about this question, it's a difference between when it's going to be available versus when I can store data in GCS. So GCS is really available pretty much in all the countries in the world where you have internet, with just few exceptions where we're not allowed to have Google services. And as we talked about our network, we have 100 points of presence around the world. And wherever you store your data, we'll be delivering it on our network to the closest point of presence. And then within public internet, within that country, even if we don't have that point of presence with Google. So really, you can store data anywhere in GCS in those locations that are available and access the data around the world. So it's really available worldwide. So second question, can I use GCS as a content delivery network or CDN? Yes, you can use it because like we talked about that edge caching, it sounds quite familiar or quite similar to CDN functionality. But really, if you want to optimize your performance, if you want to optimize your cost, you can use GCS as origin or storage for the content, and then use our Google Cloud CDN and some of our CDN partners. If you're already using CDN, it's pretty easy for you to transition. Move that origin storage into GCS while keeping your CDN provider that you're using today. And even if you don't need that CDN, even if you don't have that much public or cacheable content, GCS will serve as a basic CDN with caching that content at the edge. All right, third question. Can I control where my data is stored? Absolutely. So we have about 15 regions worldwide. As we talked about, that regional storage or using nearline and coldline in regional locations, you can select that region and store the data, your data in one of those specific locations. And we're constantly shipping new regions. So just last week, we launched 2 new regions. We launched the Netherlands region and Montreal region. And we're constantly adding more and more regions with Google Cloud Platform and GCS. And if you select a region, we'll keep data in that region. And that way, you can have highest performance between compute and storage. And on top of that, we also have 3 multi-regional locations where we take care of the geo-redundancy and replicating data across multiple regions within that multi-regional location. All right, fourth question. This question for you.
So how long does it take to transfer and load data using appliances? Is this faster than sending data over the wire? So I'll take the latter half of that question first. So you saw that very multicolored graph that I showed. You can find it on cloud.google.com/transfer appliance as well. Basically, it depends, right? Depends on your network situation and how much data you have. What we've found is that typically organizations have, a couple hundred megabit type network connection, and then they have multiple petabytes of data. So if you're in that sort of situation, then transfer appliance can make a lot of sense. Now, depending on whether or not you have less data or perhaps a faster connection, it might make sense to upload data over the wire instead. So typically, we have 2 options for transfer appliance. We have a 100 terabyte option, and we have a 480 terabyte option. Let's take the large one as an example. It could store upwards of a petabyte of data. It takes a while to load that onto an appliance. It takes a while to ship it also to you and ship it back to us. So it takes somewhere between a month and 2 months. So you got to check out what your network situation is, and it might make sense to use the appliance. It might not.
All right. So next question, is GCS or GCP storage, GCS, faster than storage on other clouds? So thinking of this question, you could look back to our architecture and all the advances that Google has made with our network. So GCS typically would be faster than other cloud providers for larger objects or when you're serving that content outside of our network, because in GCS, we're carrying data on our network for as long as possible. It's built in out of the box. You don't need to tune anything. You don't need to turn on any acceleration. We just start using GCS. We'll be carrying data on our network. So typically, you'll see GCS be faster than options out there for larger objects or for when you're serving data outside of our network. And similarly with edge caching, because by default, we have that caching in our regions around the world. If you make your objects public, we'll take it even farther out from our data centers in points of presence around the world. In those use cases, we'll also typically be faster than cloud providers because we're serving data from the edge, and you didn't have to turn on any CDNs or integrate or do any other extra work. Just works out of the box that fast with caching data on the edge. And then last question, can you speak to ratio of HDD versus SSD for different services, also different workloads? Yeah, so I don't think I can directly answer about our ratio. I don't think I should. But if you look at our pricing, you can see that pricing is pretty much HDD based because it's so cheap, 0.7 cents and 2.6 cents per gigabyte month. So you can assume that most of the data is stored on HDD to achieve that low price. But as we optimize end user performance, you will figure that our metadata is probably stored SSD probably stored in memory to achieve highest level of performance for those small object operations. And then for caching as well, you can think of different layers of cache that like some things could be cached on HDD, SSD, and even memory to achieve that highest level of performance for hot data and frequently accessed data.
Yeah.
All right. Did you want to add anything to this, or?
No, I think thank you again.
Yeah.
It's time to say goodbye from Kirkland, Washington, and we're throwing it back to Mountain View.
Thanks so much.